Hello and welcome to another tutorial of Mastering Arduino from Beginner to Core Advanced series. In module 4 we are going to deal with analog input and giving it as an output to the LED. Analog input, as we have seen previously, that analog input is the method that is used with the help of a potentiometer to show the voltage to the board and such that the board can display the voltage on the serial monitor. But here we are going to study that you can write manually analog values into the program and it will be giving as an output to the LED brightness, such that if you are given the value 255, the LED will glow to its maximum. But if we have given the value of 150, then the LED will glow up to 50%, and if you have given the value of analog write 50, then the LED will glow very dim. Okay, let's just try it with an help of an example. Okay, first of all open the Arduino. Let's just start with writing our own sketch. We want only one value, such as LED pin, which is connected to pin number 3, so we set pin number 3 as an output. Remember one thing that should be very clear, that analog output can be generated only on the pins that have a special type of symbol on it. Well, you can see here the pins that are connected to the analog have a special type of symbol on it, which is named as PWM, because analog writing in Arduino is done with the help of pulse width modulation. Okay, let's just write the program. First of all, begin with pin mode. We are doing a pin mode of pin number 3 as output. Okay, pin number 3 is set as output. Okay, we want an integer that will be storing the value for analog. We said it's integer v is equal to 0. Its initial value is 0. Okay, come here, write int. No, there is no declaration for here. V is equal to, let's say, 100. We given the value for integer such as 100. Now write analog, analog, capital W RITE, analog write. This will be calling the analog pin number 3 and giving it a value that is stored in the variable V. See the syntax: declaring an integer, calling the pin as output, giving the integer a value, and writing it is an analog format on pin number 3 with a value of integer V. Okay, let's just upload it to the board and see here. You can see that the light is glowing, but if we give the value from 100 to 200, just see the brightness of the LED. The LED turns more bright. Again, do it 100 and see here. The LED glows dim. But if you want to see real performance, set it at 10. Now see the value of the brightness of the LED. It's glowing very low. So by this method we can directly give output to an analog pin to perform the operation which happened because by writing the variable to the analog write, we are changing the duty cycle of the PWM, which in turn from digital to analog converter, which is 8-bit in 8MEGA328, that is used in Arduino Uno, will give a duty cycle which can be said as 10 divided by 255. That will be the duty cycle here. Again, make it 255. That will be the highest point of brightness. See, the LED is glowing to its brightest. If we want to see how the value is stored or how much is written in the LED, how much value has been stored in the variable, you can see here. Let's say 9600 here, and come down, write a value, serial.println. We are storing the value in V, so we are writing here. Okay, upload it. LED is brightening. Okay, see here the value is 255, that is given by analog. Well, now set it 25. The LED is glowing at a very dim pace and the value of the analog write is 25. And if you want to find the duty cycle, just do a simple division of 25 by 255, which is about 10% duty cycle. Okay, this is the method for finding the duty cycle, and by this method we can control the analog write, or you can say the analog output, with the help of simple programming. Okay, we are discussing it further in other lectures, and now if you have any questions you can ask me, and thanks for watching.